This is NASA's Ingenuity, a tiny helicopter that did something no other machine in human history has ever done. This little aircraft represents humanity's first controlled flight on another planet. And yet, despite being a technological breakthrough, Ingenuity was almost shut down before it ever reached Mars. NASA treated it like a side experiment. But what it accomplished changed the way we think about exploring other worlds. It was a proof of concept that, as far as NASA thought, didn't need to be proved. It's nothing but a tiny piece of a much larger puzzle. And that's why its story was so strange. It was essential yet ignored, revolutionary yet nearly cancelled. So let's dive into why this little machine mattered so much, and why the world's most powerful space agency barely paid it any attention. Because both have very good reasons. But before we do anything else, we first need to see how Ingenuity got to where it is. This is the Atlas V rocket, made by ULA. The specific one is the Atlas 541, and it just left Earth. The date is July 31st, 2020, one day after Atlas V took off from Cape Canaveral. But nothing has really happened yet, so let's go forward in time to when Atlas is actually close to Mars. Here we are. Atlas is just a few days from reaching Mars, but I must say, I've kind of been lying to you guys. So far, I've been showing the full rocket, but in space, the only part of the rocket that remains is its payload, the Centaur module. The rest of the rocket would have already fallen back to Earth many months ago, right after Atlas first left Earth's atmosphere. But we'll keep going. So let's see a bit more about Atlas. Here we can see the Perseverance rover. Wait, what? The Perseverance rover? I thought we were talking about Ingenuity. But that's the thing. Ingenuity got to Mars riding under Perseverance. And yeah, that's just something that NASA does, putting an $80 million helicopter under a $2 billion rover. And that's actually one of the reasons NASA didn't want Ingenuity being sent to Mars. It just takes up too much space on a rover where technology has been cramped to the breaking point, while still somehow withstanding temperature fluctuations of nearly 190 degrees, all while staying as light as possible. Perseverance is truly a marvel of modern engineering. It has to juggle thousands of different tasks in one of the harshest environments in the solar system. So NASA really didn't want precious space and weight being taken up by a helicopter. And the helicopter introduced yet another failure point. If it didn't deploy properly, it would literally be dead weight. And on a planet where dust storms have killed rovers in the past, and every bit of energy must be conserved and used to its fullest, dead weight could very well mean an early end to a mission. So yeah, NASA had its worries. But through pressure from researchers working on Perseverance, NASA caved and decided to add Ingenuity to the mission. Now that we know how Ingenuity got to Mars, let's look at what it actually is. Its weight is lighter than a laptop, or about 1.8 kilograms. Its height is 50 centimeters, rotor span 1.2 meters, and its rotor speed is 2,400 rounds per minute, which is 5 times faster than Earth helicopters. Now, keep that in mind, it may come a little bit later. Solar panels are pretty small and are just enough to survive the night. It has 2 cameras, one for navigation and another for color photos. Its flight time is 90 seconds, max altitude is 12 meters, max speed is 10 meters per second, and it has 6 lithium-ion battery cells that power everything. But there's something special about those batteries. And here's the thing, they have a problem. Mars is cold, like negative 83 degrees every single night. And cold batteries don't just lose the charge, they freeze, crack, and die. So the engineers at JPL needed a way to keep Ingenuity's batteries warm without adding weight. Their first idea? Aerogel. Aerogel is the lightest solid on Earth. A 1 gram piece would be a cube 10 centimeters wide. Its density is, wait a minute, 0.0011 grams per centimeter cubed. For comparison, water is at 1 gram per centimeter cubed. It is 99% air. It's the best insulator ever created. So why did they use it? Because aerogel was too heavy. The lightest solid on Earth was too heavy. Ingenuity had such extreme weight limits that JPL literally had to choose air over the lightest solid on Earth. It just really goes to show how tight the engineering constraints are in spaceflight. Okay, now that we have the numbers out of the way, let's look at why Ingenuity is so important. You see, it's the first time we've had controlled flight on another planet. And I have to say controlled because we've already achieved flight on another planet before. In simple terms, the Russians put a hot air balloon on Venus. And while that's technically flight, it wasn't controlled. Ingenuity is the first time we're having true controlled flight, and it's a very big deal. You see, other planets have different atmospheres, gravities, and magnetic fields. What a surprise. And on Mars specifically, the gravity is much weaker because Mars has far less mass than Earth. And the mass of the planet dictates its gravitational pull. Mars's atmosphere is much thinner and lacks an ozone layer. A thinner atmosphere means the air is less dense, and it's a lot harder for a flying machine to fly somewhere that doesn't have much air, especially a helicopter. And no ozone layer means Mars faces a constant bombardment from cosmic radiation, which is actually part of why the surface is red. And Mars doesn't have a strong magnetic field because its core isn't nearly as hot, dense, or fast spinning as Earth's core. This lack of magnetic field gives Mars even less protection against things like solar winds and flares. Between the weaker gravity and the almost non-existent magnetic field, it's no wonder why Mars has such a small atmosphere. So Ingenuity has to overcome a few issues on Mars. The first and easiest is lower gravity. Lower gravity is actually helpful because it means that you need less force to keep yourself up. So all it really needs is some recalibration of stabilization and autopilot equipment. But our next issue is the atmosphere, and it's a much bigger one. In thinner atmospheres, helicopters have a lot of trouble flying. That's why you'll never see a helicopter on Earth at the cruising height of an airliner. The air is too thin to hold it up. So Ingenuity needs to make some changes. The first change was increasing the propeller's speed. Remember the 2,400 RPM from the specs? That's about 5 times faster than a helicopter on Earth. But there's another thing engineers behind Ingenuity did. They changed the propellers themselves. They curved them a lot to create more lift. We don't curve our propellers on Earth that extremely because it would create too much drag. But because the atmosphere on Mars is so thin, there's less drag, so you need to add extra curvature to fly. And it all works out. Now, remember how Mars has neither an ozone layer or a magnetic field? Earth's magnetic field acts like a giant shield, deflecting solar winds and cosmic radiation. Mars doesn't have that. So the surface on Mars is constantly being blasted by high energy particles, cosmic rays, solar wind, and ultraviolet radiation. In Ingenuity, this tiny helicopter has to survive it all. Here's the crazy part. Ingenuity's electronics are not radiation hardened. NASA didn't use thick, heavy shielded processors that they normally put on spacecraft. They used a Snapdragon smartphone processor, basically the same kind of chip you'd find in an Android phone. Why? Because radiation hardened chips are heavy, expensive, and power hungry, and Ingenuity had none of those luxuries. So every night, Ingenuity had to survive negative 83 degrees temperatures, keep its battery warm, protect its electronics from radiation, and do all of this with almost no insulation and no power. This is why engineers expected Ingenuity to fail early, not because it was badly designed, but because Mars is brutal. And that's why NASA only planned 5 flights for Ingenuity. They expected it to fail early, so they didn't plan for much. But Ingenuity surpassed all expectations, completing a total of 72 flights over the course of 3 years, flying a total of 10.5 miles. And it could have done more, but sadly, on June 18, 2024, Ingenuity clipped its rotor on a rock during landing. And that marked the end of the helicopter that exceeded all expectations. This was my second ever video, so if you liked it, please consider subscribing. And if you have any critiques, please put them in the comments below. I have a lot to learn, so any feedback is helpful. Until next time, goodbye.